Hi, we are going to have another mini lecture today. The topic is solving a multi-step equation involving a single logarithm, type 1, type 2. So I have two problems from type 2 here, and similar problems involving natural logarithms. So I have two of them here as well. Very straightforward type of problems. Uh, what's the idea? Well, you're solving an equation now. What you're looking for is argument of a logarithm. Later on, we are going to see that there could be exponent of some exponential and so on. So, how do we go about solving these problems? Step one is to kind of ignore uh, the detail in the interior of these functions. Imagine it's just some black box. For a moment, set that aside, and so we are just going to try to aim for the box itself. What is that box? Well, that box is this base raised to power of this result. So that box is 3 to power of 3. What was in the box? So what was in the box was minus 4x plus 7. So temporarily we ignore the interior of the box. We go after the box itself. We say, what number is it whose logarithm in base 3 is going to be 3? Well, that number has to be 27. 3 to the power of 3 is 27. So now you're solving an equation that you are very familiar from early math classes. So you subtract 7 from both sides, so you have minus 4x is equal to 20, and divide by 4 and you get x is equal to minus 5, and you're all done. These problems are all to be done by hand. You don't need a calculator, and you just work it out. How about here? Well, we again, the trick is we are going to, for a moment, this complication here, we set it aside. This whole thing is some black box. We go and try to find that. If I ask you 1 plus some number is 4, what is that number? Well, that number has to be 3. Formally we say subtract 1 from both sides, so you write logarithm of 2, base 2 of minus 5x. We take 4 to the other side, or we say subtract 1 from both sides, and then you get 3. So now you have logarithm of some number. We apply the same trick as before. Logarithm of some number in base 2 is 3. What is that number? That number had to be 8. Is that right? How do you write it formally? You say minus 5x is equal to, and this base raised to power of that exponent. So that is 2 to the power of 3, which is just 8. So what should x be? X had to be 8 over minus 5. It's customary to put the minus in front, so it looks nicer. Minus 8/5, that's our answer. So in this case, we just have a logarithm here. Number is added to it. All that you have to do is to subtract. Here's another version of this thing. A number is multiplied by the entity that we put in a box first. How do we go after that? We said, well, divide both sides by the coefficient. So logarithm base 2 of 5x. Temporarily we set this aside. We say that green box has to be the right hand side minus 12 divided by coefficient of left hand side, which is minus 4, and we simplify that, we get 3. Again, logarithm of something in base 2 is 3. What is that thing itself? Well, it has to be 8. Where do you get the 8 from? 2 cubed. So again, we have x is equal to 8/5 in this problem. Next version of this problem is with natural logarithm. We want to solve this problem. All of these problems ask you to round your final answer to a certain accuracy. It says to the nearest hundredth. It also gives you a bit of a warning of what not to do. That's an issue with respect to using calculator we talked about before, that you want to delegate all the computation to the calculator and not to create intermediate steps with intermediate round off and so on. So the whole thing best be done on a calculator. So how do we approach this? First, we say we have a logarithm and another logarithm. If you remember from the rules of logarithm that the logarithm of something plus logarithm of something else can be written as the logarithm of product of those two things. So the objective here at the first stage is to compress everything into a single log so that it looks like the problems we just did. So let's do that. Logarithm of 2 times x plus 1. So what happened here? I have a 2 and I have x plus 1. I multiply them and then I take a logarithm. This is supposed to be minus 3. Okay, logarithm of something minus is minus, so I have logarithm of some, let's put a box here, logarithm of something is minus 3. Question is, what is in that box? Well, the answer is that it's a logarithm of e to the power of minus 3. That is, that box that you're after, that box, we exponentiate both sides. We say that box has to be exponential of minus 3. So here our box is twice 2 times x plus 1. That is supposed to be exponential of minus 3. Okay, I want the x, I don't want all of this. What do I do? First I divide by 2, so x plus 1 becomes 1/2 of exponential of minus 3. You can write this thing, of course, exponential of minus 3 over 2. Still, I want the x, so I subtract 1 from both sides. It becomes exponential of minus 3 over 2 and then minus 1. Okay, now let's emphasize again that in these type of problems, how we enter this item on a calculator becomes an issue. Is that well, that's a different problem, but I just want to use a calculator. So here's my calculator, and what was it that I already forgot what we had on that page? Let's see. It was exponential of minus 3 over 2, exponential of minus 3 over 2. So how do we write that? Exponential of, over there I have minus 3, I step to the right, divide by 2, and then again I forgot already, my memory is fading. So we have a minus 1. So essentially you have to type the whole thing in the calculator, and then at the end you want to find out what this quantity is. So that is doing all the steps of the calculation in the maximum amount of memory that's in the memory of the calculator, and then you don't get important round off in it. So at the end, then you are to report your final answer to, what was it, to the nearest hundredth. So nearest hundredth, let's see. So this one, you round it to 2 decimal places, and then you'll be all done. So the nearest hundredth is going to be minus 975, and then it depends how you interpret rounding here. So it will be minus 0.98 in that case. Similarly, Let's see, we had another question here. Oh, that's the problem we had over there, which was 3 logarithm of x plus 2 is equal to 15. We divide both sides by 3 first. So I'll have logarithm of x plus 2. I divide by 3, so 15 over 3 is 5. Logarithm of something is 5. What is that quantity? X plus 2 is going to be exponential of 5, and then x is going to be exponential of 5 minus 2. Now in a problem like this, there isn't really any intermediate computation to be worried about, but just to emphasize our general principle, which is to do all of it in one go. So exponential of 5, and then arrow right, and then minus, what was it, minus 2, minus 2, and then that's all there is. So 146.41, that becomes our answer. Okay, so what did we do today? We had solving equations involving logarithm, where x is in the argument of the logarithm. So basic idea was to clean out outside the exterior of the logarithm. If a number is added or if a number is multiplied, we have to get rid of those things first. Then we'll have in the format of logarithm of some expression is equal to a number. And remember, you always use this. If I have logarithm of some expression in some base is equal to some number n, then e is b to power of n. Okay, so we write it like that, and the next stage we go ahead and clean out everything that is around the x here. So we focus on that x. Here's the x. We focus on that. We have to subtract 7 from both sides and then divide by minus 4, and all the steps that are familiar to you from your algebra 1. Okay then, so until next time, good luck and God bless.